Dear students, in this video we are going to learn about the UNIX file system permissions. The outline of this lecture includes basic permissions to changing the ownerships of the file. What are file permissions? A file permission controls who can access the file, who can modify a file, who can execute a program. We can view the file permissions with the help of a command ls-l. Let us see one demo of this command. In the UNIX terminal, if we type the command ls-l, it will display the list of files and directories available in the home directory, that is present working directory. Here there are three entries are in the present working directory: file 1, file 2 and a sample. So what are these contents? The structure of file permissions indicates what type of file it is or what kind of permission it has. The first character hyphen indicates it is a file. Character D indicates it is a directory. After the first character, the remaining structure indicates what are the permissions corresponding to that file. And the remaining entries indicates who is the owner of the file, who is the group member to which that user belongs to, and what is the size of the file, and the date and time of last modification. The hyphen indicates it is a regular file. Along with regular files, there are many different files in the UNIX system. Hyphen indicates it is a regular file. D indicates it is a directory file. L indicates it is a symbolic link. C indicates character device file. B indicates block device file. P indicates it is a named pipe. S indicates socket file. Now let us understand the file permission structure. The permission structure has three parts. One for user or owner, the another part is for group, and the third part is for others. Let us interpret these permissions for the various categories of users. As I already said, the first character is to represent the type of the file, followed by the three characters, that is defining the permissions for the user. Next three characters define the type of permissions a group has. Next three characters, type of permissions others has. R indicates read permission. W indicates write permission. X indicates execute permission. If it is a file, R allows to view the contents of the file. W allows to modify the contents of the file. X indicates it is execute and it will allow to execute that program. If it is a directory, R indicates to list the files inside the directory. W indicates you can add or delete files from that directory. Execute indicates you can access into the directory by using the command cd. cd stands for change directory. You can enter into the directory. The users in Linux operating system are divided into three categories. One is user or owner of the file. G stands for group. Third category of user indicates others. Usually, user is nothing but the owner of the file, that is the person who created or owns the file. Group indicates collection of users who share permissions. Others indicate everyone else other than owner and not in the group. For an example, in a college laboratory, lab in charge is user of the lab. All the CSE department students are group members. Students from other departments belong to other category. Now let us see how to interpret the permissions for user, group and others. Here RW indicates read permission and write permission for the user. There is no execute permission, hyphen indicates. Then for groups, R is the read permission. There is no write and execute permission for group. For others also, read permission is there, no write and execute permission. In UNIX, the symbol used to represent user is U, G for group, O for others, and small a represents all the users including user, group and others. Let us check the permissions. Here is the command ls-l that displays the file structure permissions for files and directories in the present working directory. The first character indicates whether it is a file or directory. The next three characters indicates what are the permissions for the user. Next three characters indicates what are the permissions for group, and last three characters indicates what are the permissions for others. Now let us understand how to modify the file permissions. So in order to understand the modification of the file permissions, we must first understand the value of each character, read, write and execute. The numerical value for read permission is 4, the write permission is 2 and execute permission is 1. If all the permissions are there, you can give numerical value 7. Let us take one example. The command used for changing the file permissions in UNIX operating system is chmod. The syntax for chmod is chmod followed by permissions followed by name of the file. The permission can be given in two ways, either using numerical method or by using the symbolic method. If your user wants to give only read permission, he can use the numerical value 4. If your user wants to give only write permission, he can give the numerical value 2. If a user wants to give only execute permission, he can choose 1. If a user wants to give a combination of permissions, we have to add the sum of the numerical values of those permissions. For example, if the user wants to give permissions all, the sum of all three permissions is 7. So the user has to choose the number 7. If the user wants to give only read and write permission, the sum of 4 plus 2, that is 6, is to be chosen as the numerical value. The permission can be given for user, group and others. Therefore, there are 3 values in the permission list. Let us interpret the chmod command. These 3 values 755 indicates there are read, write, execute permission for the user, only read and execute permission for group, read and execute permission for others. How did we get 5? Read permission is 4, execute permission is 1. 4 plus 1, it is 5. So therefore, The chosen permissions are read and execute. So therefore the corresponding number is 5. So therefore finally the value 755 indicates the owner has read write execute permission, group has only read and execute permission, and others has read and execute permission. This numerical value is to be used along with the file name in chmod command. Example, chmod 644 index.html. Index.html is a file which has read write permission for user, only read permission for group, only write permission for others. 644 indicates 700 indicates all permissions for user, no permission for group, no permission for execute. Others. 700 only permits read write execute permission for users. There will not be any permission for group and others. Let us have a demo of this chmod command. Now I would like to change the file permissions for file 1. Initially the file 1 is having the file permissions read write. Read write put together 6. Only read permission it is 4 for group, 4 for others. So the initial file permission for file 1 is 644. Now I want to change the 644 into 755. That means all permissions for group. Read and execute permission for group and read and execute permission for other. chmod 755 for file 1. Now let us see the file permission with ls-l command for file 1. Now let us see the difference between the previous permission structure and the present permission structure. So the permissions are changed. For user, read, write, execute permissions are given, whereas there is no execute permission in the previous. Read and execute permission for group is given. Read and execute permission for others are also given. So in that way, we can change the permissions using the chmod command. Now let us have the symbolic method of changing the file permissions using the chmod command. Here U stands for user, G stands for group and O stands for others. We use the 3 characters plus for adding permission, minus is for removing the permission, equal to for setting the permission, irrespective of what permission previously the file has. Now let us see the demo of this chmod command using the symbolic method in the terminal. Here I am going to change the file permissions for file 2. chmod U stands for user. I am adding the execute permission because there is no execute permission for file 2. For user I am giving the execute permission for file 2. Now see the output ls-l. See, read, write, execute. So execute permission is added to file 2. Similarly, I want to add execute permission for others. chmod O stands for others. For others, I am adding the execute permission for file 2. Now see the output. For others, X is added. In that way, we can also remove the file permission. chmod for others, I am going to remove the read permission for file 2. So there is no read permission for file 2. There is no read permission for file 2. Similarly, we can control the file permissions for everyone by using the command chmod. A stands for all. I remove read permission for file 2. So ls-l file 2, it is removing the read permission for everyone. Similarly, you can add for others both read write permission for file 2. So now read write permission was added to others. For adding read write permission for all, A stands for all. A plus read write permission for file 2. So read write permission, read write permission, read write permission for all the categories of users. In this way, we can control the permission for a file by using chmod command. Plus for adding the file permission, minus is for removing the file permission. U stands for user, G stands for group, O stands for others, A stands for everyone. Here is another example. G minus W file.txt. This will remove the write permission for groups. O is equal to R. That means irrespective of whatever file permissions are there earlier, they are all revoked and only read permission is given for others. So let us have a demo of this example. Chmod for others is equal to only read permission for file 2. What are the permissions? Read, write, execute. All the three permissions are there for file 2. Now I am giving only read permission. Yes. So only read permission is been given to file 2. So in that way, by using these symbols, we can control the file permissions in UNIX operating system. Common permission scenarios. 755 is generally the file permissions given to the directories. This allows everyone to access and control the directories, and if it is private scripts, only 700 permission is chosen. If it is data file, 644 permission is given. That indicates the read access for groups and others, read write access for owner of the file. So in that way, the common permission numbers are chosen like this. The permission management workflows. First, ls-l command is used for identifying the list of permissions available, users, groups and others. Then use chmod command for changing the file permission either by using the symbolic code or else the octal equivalent number. Finally, recheck the modified file permission by using the ls-l command. Thank you for watching this video.